The effect of changing h. We're looking at the equation of a parabola that's in this form. Okay, this is called, we're tying it all together today. This is called vertex form. Yesterday you looked at the effect of changing a. What does a tell you? Let's just do a quick review. Okay, so a tells us if it's going to open up or down, if it's going to be skinnier or wider. What does k tell you? Remember this from yesterday? So k tells us if it's going to shift up or down. Does anyone have a prediction about what h might be? If it's shifting side to side, let's check, okay? Okay, so as we can see, we have our parent function, which is y equals x squared, which is right at the origin. I'm not stretching or compressing these. I'm only moving them to the left or right. If it's x take away 2 squared, it moved to the right. Okay, so it's moving to the right. So when it's subtract, it moves to the right because this is actually a positive number. And then the second example, the yellow one, it's x take away a negative, right? X take away a negative 2 becomes x plus 2. This one moves to the left. It shifts left across the x-axis. So in this example here, this is h. H is what? What value is h? It's a positive 2. Here, the value of h is a negative 2. Okay? When you plug it into the equation, though, it becomes x minus 2. Because the equation in vertex form is y equals a x minus h squared plus k. You're just replacing the h. So when h is a number that's greater than 0, if h is greater than 0, it's going to move to the right or left of the y-axis. It's going to move to the right. And the equation will look something like this. X minus, let's say, 5 squared. If h is less than 0, which way is it going to move? To the left. Because when you're plugging in, you're only replacing the number, right? So it's going to be x. You always leave it as x minus. Well, if h is less than 0, give me a number that's less than 0. Negative 3, okay? It becomes plus 3. So when you're looking at the two equations, if it's take away something, it's moving to the right. If it's plus something, it's moving to the left. It's the opposite sign, okay, in your mind. Okay, so this is the parent function, right? Y equals x squared. Where does it start? 0, 0, right? This is the vertex, 0, 0. You should be able to graph this, okay? So you're going to go over 1 and up 1, and you're going to plot the next point. Well, remember I told you that parabolas are symmetrical. If I go over to the left 1 and up 1, what should I do to the right side? Same thing. Over 1, up 1. Let's plot the next point. From there, we're going to go over 1, up 3. So 1, 2, 3, and plot the next point. Same thing on the right side. Over 1, up 1, 2, 3. And then the last point, again, we're going over 1, this time up 5. 1, 2, 3, 4, 5, and we'll plot the last point. Same thing on the right side, over 1, up 1, 2, 3, 4, 5. And now I'm going to connect the black dots with a smooth curve, and that is my parent function. That's the parabola. Okay, so again, we're always going over 1, and then it's going to be up 1, then up 3, then up 5. So the step pattern, when you're moving up, what's the step pattern? We move up 1, and then we move up 3, then we move up 5. What do you think the next one would be if we were to graph this? 7, good. It's increasing by 2 every time. Okay, good. This is for the parent function only, okay? Now we're going to try graphing y equals x minus 5 squared. Because it's x, bless you, minus 5 squared, Where will this shift? Where would this start on the graph? Where's the vertex going to be located? It's not going to be at 0, 0 anymore, like the last one. Where will this one be? 5, 0. Good. So it's shifting to the right. Now just graph it using the step pattern. There's no stretch or compression because A is a 1. So there's actually no stretch or compression. So we follow the step pattern of 1, 3, 5. So over 1, up 1. Over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. And do the same thing on the right side. Okay, and then we can graph it. Oops. Oops. Yeah, my bad. Has to be symmetrical. Okay, so you just graphed two parabolas. You graphed the parent function, and now we shifted that original to the right 5 units because the equation changed. Based on what we just learned about h, what's my h value in this equation? Positive 6, right? It's just 6. What's the a value in this equation? Negative 0.1. Good. So based on what you learned yesterday, will this open up or down? Good. Will it be stretched or compressed? Who remembers? If it's a decimal? Good. It's compressed. Is this going to shift up or down? No. What's k? K is 0. I'm not dealing with k right now. It's 0. So it's not going to shift up or down. How is it going to shift? Is it going to shift left or right? It's going to shift to the right. How many units? So where will the vertex be for this one? 6, 0. Good. Is this going to open up or down? Will it be stretched or compressed? Is it going to shift left or right? Good. How many units? So where's the vertex? Okay, so this is the parent function. That's the parent function. That's the parent function, and that's the parent function. We're going to look at how it shifts. So for A, which way did the parabola move? Yes. How many units did it move? If you look in your textbook, you can count. Yes, it is 6. Does this look like it's been stretched or compressed? Stretched. Good. Okay, B. Good. It moves left 4. Is it stretched or compressed? Good. Listen up. Shh. For C, it opens down. We can say that it's been reflected in the x-axis, okay? But has it been stretched or compressed? Good. It's been compressed because it's cut off. It should extend like this. Like they just cut it off on the screen. Yeah, because it should be symmetrical exactly. And did this one move to the left or right? Right? How many units? Who can see? Good, perfect.
Made with Doodlecast Pro.